So, just briefly, here's the show list function, if you were curious about how to do that. It's not too bad, just add a little thing at the beginning. We use our same step 1, step 2, step 3, and then print out each of the values. Alright, so moving on to prepend. Let's look at the prototype for prepend. So here, we add an element to the front of the list, and prepend returns a struct node pointer. So we're going to be returning a pointer. And it takes in a list, of course, and it takes in data to go in the element at the beginning of the list. Alright, now the reason why we have to return a struct node pointer is because we might be changing the front of the list. Now if we change the front of the list inside the prepend function, we have to return the pointer because only things inside the function get changed. Let's have a look at how we call prepend. So I have already written here a test list file. And this is how we call it. So if we have a test list here, we create a create list and assign it to test list. Then we go test list is equal to prepend test list and then the number that we want to prepend. So that is how we're going to call our prepend function. Now let's have a look at how to implement it. So we'll go back over to our list.c and we'll paste in the prototype for prepend. Alright. Now let's look at how we're going to do this. It's actually quite simple. As you might recall from Mark's diagrams, we want to avoid losing any part of the list. So we must always keep pointers to our list. Let's create a temporary variable. Struct node pointer temp. Let's make that equal to list. Alright. And then we simply do list is equal to new node data temp. Now what's going on here? It's okay to override list. We won't lose everything because we have another pointer to it already. We made this temp. But what's happening with our new node function? Well, we have new node written down here. And what does it do? It takes in the data and it takes in a pointer, right? And its job is to allocate memory for the node and assign the items passed in to the node. So let's look at that. We have malloc, the size of struct node. Now struct node, if we get the size of that, that will calculate all the elements of the struct and add them all together and return the total size in bytes. And malloc will allocate memory for that many bytes and return us a pointer. So that's our pointer, new. Now because new is a pointer, we use the arrow notation to assign data. Now data comes from the argument passed in. And next is also passed in. All that's left to do is return new. Alright, so there's one last thing to do in prepend. We have to make note of the return type. We have to return the list. So let's do that. Return list. And our new node is the new head of the list. So that's prepend. Alright, now let's look at how to code the append function. Let's make a prototype for that. Now if you recall, append means to add an element to the end of the list. So similar to prepend, we'll be returning a pointer, a node struct node pointer. Now why is that? Because we might be appending to an empty list, and if we're appending to an empty list, that means the start of the list has to change. And if we recall, if the start of the list changes, we have to return the beginning of the list. So we're taking in struct node pointer list, just like before, and then int data. Alright, now let's look at how to code this one. So we'll come down to the bottom of our file here and paste the prototype. Alright, so this function uses our step 1, step 2, step 3 template. So let's have a look. Let's go and copy that template. Okay, I've pasted in our template. So step 1, step 2, and step 3. Now let's modify our template so that it works with append. And what we have to do with append is we have to traverse the list. We have to iterate all the way to the end and then add on our new element. So to do that, we'll need to do our step 1, make a current to keep track of where we are in the list. Then we'll need to use a loop to iterate through to the end. But there's one small difference here. We want to change the condition. We want to change that to current next not equal to null. Now why is that? That's because we want to stop one before so that we can change that node to point to the new node that we're adding to the end. So after the while loop, we will be at the end of the list. So all that's left to do is to add the new element. And we have our handy helper function to do that. So we can do current next is equal to new node. Now we're passing in the data that was passed into the append function, and null, because null goes at the end of the list, and this node is going to be at the end of the list, or the second last element. Sorry, not the second last element, the last element. Then, like before, we will return list. Now there's one thing that we haven't accounted for. What will happen if we pass in an empty list? List here, what if that's equal to null, right? We need to, well, what will happen is current is equal to list here, and then we have current next. Now this is a problem because we know current is equal to null because list was equal to null. But you might know that if you use the arrow to dereference a pointer and that pointer is null, then you get a segmentation fault. And they're not great. We want to try and avoid those. So you should always consider, especially if you're getting a seg fault, first thing to look at is the arrows. Have a look at the thing that comes before the arrow and consider, can that be null? In this case, it can be. So we have to add a case in for the case where list is null. So I'll put here empty list case, and we'll have if the list is equal to null, i.e. if it's empty, then let's just return a new node with the data and null. Alright, there we have it. That's our append function. We've used our step 1, step 2, step 3 template, and we've also considered the empty list case. Alright, so we're up to implementing our sorted insert function. And this one's a little more challenging, but it's not too bad. If you understood the previous examples that we've covered, it's more or less the same, piecing together bits that we've already covered. Let's look at the prototype. Okay, So I'll write a comment first describing what the function will do. Alright, so just to remind you, we are given a sorted list and we want to insert a new element into that list so that the resulting list remains sorted. Alright, like before, we will return a struct node pointer because it's a possibility that we'll be inserting at the beginning of the list. We'll be taking in a list and we'll be taking in an element or data to go in one of the nodes. Alright, let's jump over to our list.c file and we'll go to the bottom here and we'll paste our prototype. Alright, so what things will we need here? Let's start with what we had for our append function, right? We'll start there. So let me paste in what we put in our append function. If you recall, we have our step 1, step 2, step 3. We also have an empty list case, and we have something that happens when we reach the end of the list. Alright, so let's modify this a bit. Firstly, we don't want to append the node, so let's take out this bit for a second. Alright, next, let's have a look at our while loop condition. Think about that. We want to iterate through the list using a loop, and null is at the end. So that's okay, we can loop through our list, and then as we're looping through, let's check. We can stop one element before the target position. Alright, let's use an if statement to do that. If data is smaller or equal to current next data. So why have we chosen this for our if condition? Well, we are inserting a new element. Now think back to the diagrams. We're inserting a new element. We want to go along our list. Remember, the small elements will be at the beginning of the list, and the large elements will be at the end of the list. And the right place for our new element is between, so that before is smaller and after is bigger. Now if we use this condition, data is smaller or equal to current next data, it will trigger this if statement when it is one element before a node that has data that is bigger. Now try drawing that out and convince yourself that that works. Here we go. So once we're in here, we know we have the right place to put our node. So as before, let's make a temp so we don't lose our pointers. We'll put a struct node pointer temp, and let's make that equal to current next. Then we can say current next is equal to new node data temp. And then finally, that means we have now inserted our new node into the correct position, right? So we made temp equal to current next, and that's the next element along. Then current next is equal to our new node, and new node's next is equal to current next. So it's like squeezing our new node in between the two elements. Again, it's always good to draw this out, so draw out your own diagrams. You can see. Now that we've inserted our new element, we don't need to continue iterating through our list. So we can return here. Let's return list, the head of the list. We're not quite done yet. There's another case to consider, right? Consider what would happen if the data to be inserted is smaller than any other element in the list. So that means it has to go at the beginning of the list. Well, what will happen is we will get to our while loop condition. Current next is not equal to null. That's fine. But if we go in here, we've already passed over the first value because we're looking at the value after the one we are currently at. That's why we're looking at current next data. So we need to make a case for if we are inserting at the beginning of the list. So let's do that. After we check the empty list case, let's check for beginning of list case. So if data is smaller or equal to list data, that is the first element, then let's just prepend to our list, where we can use our function that we wrote before. That's not too bad. Alright. So we've handled the empty list case, we've handled the beginning of the list case, and there's one more thing we need to consider. And this while loop will take care of if we're inserting the element somewhere in the middle. But what if we are inserting in the last element? Well, if you recall the append function, we used this while loop, and only at the end of the while loop, after it had finished, were we at the end of the list. So, at the end of the while loop, we're at the end of the list. Let me just write that out. So our while loop will continue going until we either find the correct position for the element or we reach the end of the list. So if we've reached this point, we have reached the end of the list, and the item passed in data must be the biggest value in the list so far. So let's simply append it to the list. So list is equal to append list data. Alright, and then we can return list. Now if you like, you can combine these steps like we did before. And there we go. That is our entire sorted insert function. What have we got? We're considering the empty list case, the beginning of the list case. We've got our step 1, step 2, step 3 to handle if we're inserting in the middle of the list. And then finally at the end, we've got the end of the list where we append. Alright, so now we've seen a function like that, see if you can implement that function yourself. And if you're ready for an extra challenge, try writing a function to insert a new node at a given index in the linked list. So that's the end of our second video. We've looked at prepend, append, and sorted insert. In the next video, stay tuned and we'll talk about the delete function and look at some extra functions.